April 18, 1943. High above the dense jungles of Bougainville, 16 American P-38 Lightning fighters sliced through the tropical sky like silver daggers. Their mission: intercept and eliminate the architect of Pearl Harbor himself, Admiral Isoroku Yamamoto. The odds? Impossible. The distance? Beyond the range of any fighter in existence. The stakes? The entire Pacific War. But inside those twin-boomed aircraft flies something the Japanese never expected. An idea so radical, so seemingly absurd, that nearly every engineer in America called it idiotic. One man believed otherwise. And his obsession with an impossible design would turn the tide of the largest air war in human history, destroying over 5,000 Japanese aircraft and changing aerial combat forever. This is the story of how madness became genius, and how a plane that shouldn't exist became Japan's worst nightmare. The year is 1936, and the world stands on the precipice of unimaginable destruction. In the dusty hangars of Lockheed Aircraft Corporation in Burbank, California, a 34-year-old engineer named Clarence Kelly Johnson stares at a set of military specifications that seem designed to be impossible. The United States Army Air Corps wants a fighter. But not just any fighter. They want an interceptor capable of reaching 360 miles per hour at 20,000 feet, with an operational ceiling of at least 20,000 feet, and capable of climbing to that altitude in 6 minutes. In 1936, this is essentially asking for a flying unicorn. The fastest fighters in the world can barely touch 300 miles per hour. Kelly Johnson reads these requirements and sees something everyone else misses. He sees the future of air warfare written in impossible numbers. Johnson's colleagues think he's lost his mind when he proposes his solution. Twin engines. Twin booms. A central nacelle for the pilot suspended between them like a gondola hanging between two mountains. It violates every principle of aircraft design established since the Wright brothers first flew at Kitty Hawk. Conventional wisdom says fighters must be small, light, single-engine machines that can twist and turn like sparrows. Johnson's design looks like someone welded two planes together with a bathtub in the middle. The mockery is immediate and relentless. It'll never fly, the critics say. Too much drag, they insist. Aerodynamically absurd, they conclude. Even Lockheed's own management hesitates. But Kelly Johnson possesses something more powerful than conventional wisdom. He possesses vision. And an almost supernatural understanding of airflow, stress dynamics, and the mathematics of flight. Behind closed doors, Johnson works 18-hour days, filling notebooks with calculations that would make most engineers weep. The twin-boom design isn't insanity, it's brilliance disguised as madness. By separating the engines and mounting them on extended booms, Johnson solves multiple problems simultaneously. The design eliminates the torque that makes single-engine fighters pull to one side during takeoff and combat. It provides redundancy: lose one engine, you can still fly home. It creates perfect weight distribution. And perhaps most ingeniously, it leaves the entire nose of the aircraft free for armament. No guns firing through propeller arcs. No synchronization mechanisms. Just pure, concentrated firepower pointing straight ahead like a cannon. But convincing the Army to take a chance on this bizarre-looking machine requires more than mathematics. It requires a leap of faith. January 27, 1939. Edwards Air Force Base, California. Lieutenant Ben Kelsey climbs into the cockpit of the XP-38 prototype for its first official flight. The sleek, silver machine sitting on the runway looks like nothing else in the sky. Twin Allison V1710 engines, each producing over 1,000 horsepower, rumble with barely contained power. The twin booms sweep back like the wings of some predatory bird. Kelsey advances the throttles and the XP-38 leaps forward with shocking acceleration. Within seconds he's airborne, climbing at a rate that makes his eyes water. The speed is intoxicating, terrifying, incredible. At altitude, Kelsey pushes the aircraft to its limits. 350 miles per hour. 400. 417 miles per hour. The XP-38 isn't just fast, it's the fastest fighter in the world by a massive margin. Kelsey grins behind his oxygen mask. Kelly Johnson's idiotic idea just became America's secret weapon. But the road from prototype to production is paved with disasters that would break lesser men. On February 11, 1939, Kelsey attempts a transcontinental speed record flight to demonstrate the XP-38's capabilities to skeptical Army brass. He roars across the country in 7 hours and 2 minutes, shattering every existing record. But on approach to Mitchell Field in New York, disaster strikes. Ice clogs the carburetor intakes. Both engines sputter and die. Kelsey has no choice but to attempt an emergency landing. He brings the powerless Lightning down on a golf course just short of the runway, and the prototype, the only XP-38 in existence, crumples like aluminum foil. Kelsey walks away with minor injuries. The program appears dead on arrival. The critics sharpen their knives. "We told you so," they whisper. But they don't know Kelly Johnson. They don't understand that failure only makes him more determined. Johnson tears into the wreckage like a forensic detective examining evidence at a crime scene. Every bent strut, every twisted panel, every failed component tells a story. He redesigns the carburetor system. He modifies the engine cooling. He strengthens the landing gear. He addresses every weakness the crash revealed. By 1941, the refined P-38 Lightning begins rolling off production lines, and suddenly the Army can't get enough of them. Because by now, the world has exploded into global warfare. Hitler's Luftwaffe dominates European skies. Japan's Zero fighters rule the Pacific. And America desperately needs something that can fight back. The P-38 isn't just fast, it's a revelation. At high altitude, nothing can catch it. Its 4.50 caliber machine guns and 120mm cannon concentrated in the nose create a cone of destruction that can saw enemy aircraft in half. The twin-engine reliability proves invaluable over vast Pacific distances where a single engine failure means death in shark-infested waters. December 7, 1941. Pearl Harbor burns. The Japanese attack catches America's Pacific Fleet with its pants down, destroying battleships, killing thousands, and plunging the nation into war. In the months that follow, Japan seems unstoppable. Wake Island falls. Guam falls. The Philippines fall. Japanese forces sweep through Southeast Asia like a tsunami. Their Zero fighters dominate every engagement, their experienced pilots decimating American aircraft with contemptuous ease. American pilots flying obsolete P-40 Warhawks and P-39 Airacobras face a brutal reality: they're outclassed, outflown, and dying in horrifying numbers. The losses are catastrophic. Morale plummets. Then the first P-38 Lightnings arrive in the Pacific Theater, and everything changes. The Japanese pilots have never seen anything like the Lightning. It appears in the sky like some alien craft, twin-boomed and impossibly fast. When American P-38 pilots dive on Japanese formations, the Zeros simply cannot respond. The Lightning dives faster than physics should allow. It climbs like it's being pulled by invisible cables. And when its concentrated nose armament opens fire, Japanese aircraft disintegrate. The psychological impact is immediate and devastating. Japanese pilots start calling the P-38 the fork-tailed devil, and 2 planes, 1 pilot. They fear it more than any other American fighter. Intelligence reports from captured Japanese documents reveal orders specifically instructing pilots to avoid engaging P-38s unless absolutely necessary. Think about that. The same pilots who bombed Pearl Harbor and terrorized the Pacific for over a year are now told to run from the Lightning. Kelly Johnson's idiotic idea has become Japan's recurring nightmare. But the P-38's greatest moment, the mission that would prove its devastating capabilities beyond all doubt, is still to come. By early 1943, American codebreakers have achieved something extraordinary. They've cracked the Japanese naval codes. They're reading enemy communications in real time, knowing Japanese movements before some Japanese commanders know them. On April 13, 1943, cryptanalysts intercept a message that makes their hearts stop. Admiral Isoroku Yamamoto, the mastermind of Pearl Harbor, the architect of Japanese naval strategy, will be conducting an inspection tour of forward bases in the Solomon Islands. The message includes his complete itinerary, down to departure times and arrival schedules. In military terms, this is the intelligence coup of the century. But reading a message and acting on it are two very different things. The problem seems insurmountable. Yamamoto will be flying in a bomber escorted by Zero fighters. The interception point lies over Bougainville, deep in Japanese-controlled territory, hundreds of miles from the nearest American base at Guadalcanal. It's beyond the combat radius of every American fighter except one. Only the P-38 Lightning has the range to fly that far, engage in combat, and return home. Even then, it requires flying at the absolute edge of the aircraft's capabilities. Every fuel calculation must be perfect. Every navigation decision must be flawless. There is zero margin for error. 1 degree off course and they'll miss Yamamoto entirely or run out of fuel over empty ocean. The mission borders on suicide. Admiral Mark Mitcher, commander of air operations in the South Pacific, makes a decision that will echo through history. He authorizes Operation Vengeance. Major John Mitchell receives the mission briefing and feels ice water in his veins. He'll lead 18 P-38 Lightnings on a 435-mile overwater navigation flight at wavetop altitude to avoid Japanese radar. They'll time their arrival to intercept Yamamoto's bomber exactly as it descends for landing. They'll fight through the Zero escorts, shoot down the Admiral's plane, and somehow make it home. Oh, and they have to maintain absolute radio silence the entire way, navigating by dead reckoning over trackless ocean. Mitchell looks at the young pilots selected for the mission. Captain Thomas Lanpher. First Lieutenant Rex Barber. Lieutenant Besby Holmes. Lieutenant Jim McClanahan. Kids really? Most barely in their 20s. Some with girlfriends waiting at home, some with young wives, all with parents who pray for their safe return. Mitchell knows the odds. Maybe half make it back. Maybe fewer. But this is Yamamoto, the man who planned Pearl Harbor. The opportunity may never come again. April 18, 1943. 7:10 a.m. 18 P-38 Lightnings launch from Fighter II airstrip on Guadalcanal. The weather is perfect, too perfect almost. Clear skies over the Solomon Sea, gentle winds, visibility unlimited. Mitchell leads them low, so low the propellers nearly kiss the wave tops, flying in radio silence with nothing but Mitchell's navigation skills between success and disaster. For over an hour and a half, they roar across empty ocean. 18 twin-boom shadows racing over blue water. The fuel gauges slowly drop. Everyone aboard knows they're committed now. Too far out to turn back. Too deep into enemy territory to expect rescue if something goes wrong. The only direction is forward. Mitchell checks his calculations obsessively. Every minute matters. Every mile counts. At exactly 9:35 a.m., they make landfall at Bougainville right on schedule. Mitchell's navigation is perfect. Now comes the hard part. They climb, gaining altitude rapidly, the Lightning's powerful engines pulling them skyward. And there, precisely where intelligence predicted, 2 green Japanese bombers appear, flanked by 6 Zero escorts. Yamamoto's plane. Mitchell's voice crackles over the radio, breaking the hours of silence. Bogies. 11 o'clock high. The formation splits. Mitchell leads the top cover group to engage the Zeros. Lanpher and Barber dive toward the bombers like hawks stooping on prey. The Zeros react instantly, braking hard to intercept. And now the sky over Bougainville erupts into swirling chaos. P-38s and Zeros mix in a deadly three-dimensional chess game played at 300 miles per hour. Tracers stitch the air. Engines scream. The Japanese pilots are good, veterans of countless battles, survivors of brutal combat. But they've never fought P-38s in numbers like this before. Lanpher sees Yamamoto's bomber trying to escape at treetop level. He dives, pushing the Lightning past its maximum speed. The airframe shudders. The controls stiffen. Behind him, a Zero closes in, cannon fire walking up toward his tail. Lanpher ignores it, focusing everything on the bomber ahead. Distance collapses. 500 yards. 400. 300. At 200 yards, Lanpher squeezes the trigger. The P-38's concentrated nose armament, 4 machine guns and 1 cannon, erupt in a sustained burst. The bomber staggers as rounds tear through its fuselage. Smoke pours from the right engine. The bomber rolls hard left, trying desperately to evade. But it's too late. The damage is catastrophic. Lanpher pours another burst into the doomed aircraft. The bomber's wing tears away. It spirals downward, smashing into the jungle canopy and exploding in a fireball that sends a column of black smoke towering into the tropical sky. Meanwhile, Rex Barber engages the second bomber, which has broken away and is fleeing west. Barber is relentless, chasing it through a storm of anti-aircraft fire from Japanese positions below. He closes to point-blank range and unleashes everything the Lightning has. The bomber explodes in midair, debris tumbling into the ocean. 2 bombers. 2 kills. In less than 2 minutes, the P-38s have achieved their impossible mission. But the fight isn't over. The sky is still full of angry Zeros, and the Americans are deep in hostile territory with fuel gauges showing dangerously low levels. Mitchell's voice cuts through the chaos. Break off. Head for home. The P-38s disengage, using their superior speed to leave the Zeros behind. They dive back to wavetop altitude and point their noses toward Guadalcanal. The flight home is agonizing. Every pilot watches his fuel gauge with mounting dread. The needles drop toward empty with terrifying speed. Some pilots shut down one engine, flying on a single Allison to conserve fuel. The math is brutal. They're still over 100 miles from base. They might not make it. One P-38 sputters, its engine starved of fuel. The The pilot ditches in the ocean and is never seen again. The others press on, willing their aircraft to keep flying. Guadalcanal appears on the horizon like a mirage. The Lightnings stagger in one by one, some landing with fuel tanks literally bone dry. Mechanics later find some planes with less than 5 gallons remaining, barely enough to taxi. 17 P-38s return. 1 pilot lost. 2 Japanese bombers destroyed. And Admiral Isoroku Yamamoto, architect of Pearl Harbor, is dead. The impact of Yamamoto's death on Japanese morale cannot be overstated. He was irreplaceable, a strategic genius, a beloved leader, a symbol of Japanese naval supremacy. His loss sends shockwaves through the Imperial Japanese Navy's command structure. They hide his death for weeks, terrified of the psychological blow it will deliver. When the news finally breaks, Japanese sailors and pilots are devastated. But more importantly, the mission proves something vital about the P-38 Lightning. It can strike anywhere at any time, far beyond what the Japanese thought possible. The fork-tailed devil has just killed the most important military figure in the Pacific, and there's nothing Japan can do to protect against it. From 1943 onward, P-38 Lightnings dominate Pacific skies with merciless efficiency. American pilots flying the Lightning rack up staggering kill counts. Major Richard Bong shoots down 40 Japanese aircraft, the highest-scoring American ace of all time. Major Thomas McGuire claims 38 kills. The list goes on and on. But it's not just about individual aces. It's about systematic destruction. Every bomber formation Japan sends meets P-38s. Every transport flight risks Lightning interception. Every Japanese airfield within range becomes a target for Lightning fighter bombers. The P-38 doesn't just fight, it hunts. Kelly Johnson's design proves perfect for the vast distances of the Pacific. Pilots flying dangerous missions over hundreds of miles of ocean trust the twin-engine reliability completely. Lose one engine to combat damage or mechanical failure. No problem. Fly home on the other one. This redundancy saves hundreds of American lives. The Lightning's concentrated nose armament revolutionizes air combat. Previous fighters scattered their guns across the wings, creating convergence problems. The bullets only concentrated at a specific distance. The P-38's nose mounting means every round flies parallel. Point the nose at an enemy aircraft and everything hits. Japanese pilots quickly learned that even a 1-second burst from a Lightning can be fatal. The 4.50 caliber machine guns and 20 mm cannon create a stream of destruction that saws through enemy aircraft like a chainsaw. Captured Japanese documents reveal desperate attempts to counter the Lightning. They try heavier armor on their fighters, it makes them too slow. They develop new tactics, the P-38 speed negates them. They train pilots specifically to fight Lightnings. Those pilots die anyway. There is no good answer. The P-38 is simply superior. By 1944, the Lightning's role expands beyond fighter duties. The aircraft proves remarkably adaptable. P-38s equipped with underwing drop tanks become devastating fighter bombers, striking Japanese ships, airfields, and ground installations with pinpoint accuracy. The Droop Snoot variant carries a bombardier in a modified nose, leading formations of bomb-laden P-38s against heavily defended targets. Photo reconnaissance versions with cameras instead of guns photograph Japanese positions from altitudes where anti-aircraft fire can't reach them. The P-38 becomes a Swiss Army knife of aerial warfare, equally capable of dogfighting, ground attack, bombing, and reconnaissance. Kelly Johnson's Idiotic idea has evolved into the most versatile combat aircraft in the Pacific theater. The statistics are staggering and brutal. By war's end, P-38 Lightnings are credited with destroying over 5,000 Japanese aircraft, more than any other Allied fighter in the Pacific. 5,000. Let that sink in. That's not 5,000 missions or engagements. That's 5,000 enemy aircraft shot out of the sky or destroyed on the ground. Each one represents a Japanese pilot killed or captured, a machine that took months to build reduced to twisted wreckage in seconds. Each one is a small victory in the grinding arithmetic of total war. The Lightning's loss ratio is extraordinary. For every P-38 lost in combat, American pilots destroy multiple enemy aircraft. The numbers don't lie. The fork-tailed devil lives up to its nickname, spreading terror across Japanese-held territories from New Guinea to the Philippines, from the Solomons to Okinawa. But the human cost behind those numbers tells a deeper story. Young American pilots climb into P-38 cockpits knowing they might not return. The Pacific theater is unforgiving. Bail out over the ocean and you face exposure, dehydration, sharks, or capture by Japanese forces who often execute downed pilots. Mechanical failure at the wrong moment means death. A single bullet through a vital system means death. The men who fly the Lightning understand these stakes every single time they strap in. Yet they fly anyway. They fly because the alternative, letting Japan win, is unthinkable. They fly because their brothers in arms depend on them. They fly because somewhere back home, families pray for their safe return and victory. And they fly because the P-38 Lightning gives them a fighting chance. The Pacific War grinds on with apocalyptic intensity. Island after island falls to American forces in campaigns of extraordinary brutality. Tarawa, Saipan, Iwo Jima, Okinawa. Each landing is covered by P-38's flying combat air patrol, protecting vulnerable ships and troops from Japanese air attacks. Each invasion is preceded by Lightning fighter bombers destroying Japanese positions. The P-38 becomes synonymous with American air power in the Pacific. Japanese soldiers learn to fear the sound of twin Allison engines approaching. That distinctive sound means death is coming. It means bombs, bullets, and no escape. It means the Americans control the skies, and no amount of courage or determination can change that fundamental fact. By mid-1945, Japan's air forces are shattered. The 5,000 aircraft destroyed by P-38s represent an irreplaceable loss. Japan's pilot training program cannot keep pace with the losses. Replacement aircraft grow increasingly scarce as American bombing destroys factories and raw materials dry up. The pilots who remain are often inexperienced teenagers with minimal training, thrown into combat against battle-hardened American veterans flying superior aircraft. It's not a fair fight. It's not supposed to be. War isn't about fairness, it's about winning. And by every measure, the P-38 Lightning is winning. The fork-tailed devil has achieved what seemed impossible in 1936. Total air superiority over the largest ocean on Earth. August 1945. The atomic bombs fall on Hiroshima and Nagasaki. Japan surrenders. The war ends. P-38 pilots fly their final combat missions and return to bases that suddenly seem too quiet. The engines shut down for the last time. The guns fall silent. The immediate reaction is relief, they survived. They're going home. But in the years that follow, as veterans gather at reunions and share stories over drinks, a common theme emerges. They loved the Lightning. It was fast, powerful, reliable, and forgiving. It brought them home when by all rights they should have died. The P-38 saved their lives and they never forgot it. Kelly Johnson's idiotic idea became more than a successful weapons system. It became a lifeline, a guardian angel wrapped in aluminum and engineering genius. Kelly Johnson himself goes on to design some of aviation's most iconic aircraft. The U-2 spy plane. The State Route 71 Blackbird. But the P-38 Lightning remains special. His first major success, the aircraft that proved his revolutionary thinking correct. In the decades after the war, Johnson occasionally speaks about the Lightning's development. He never expresses regret about the unconventional design. He never apologizes for ignoring critics who called it impossible. Instead, he speaks with quiet satisfaction about solving problems everyone else thought unsolvable. That's the essence of innovation. Seeing possibilities where others see only obstacles. The P-38 Lightning succeeded because Kelly Johnson refused to accept conventional wisdom. He trusted mathematics over opinions, vision over tradition, and his own genius over the skepticism of lesser minds. The legacy of the P-38 Lightning extends far beyond World War II. It influences fighter design for generations. The twin-boom configuration appears again in later aircraft. The concept of concentrated nose armament becomes standard. The emphasis on speed and altitude performance shapes jet fighter development. Modern military aviation owes a debt to Kelly Johnson's idiotic idea. But perhaps more importantly, the Lightning represents something essential about American engineering and innovation during World War II. When faced with seemingly impossible requirements, American engineers didn't say it couldn't be done. They rolled up their sleeves and did it anyway. They took risks. They challenged assumptions. They built weapons that were years ahead of anything the enemy possessed. The P-38 Lightning is a case study in how radical thinking combined with rigorous engineering can change the course of history. Today, only a handful of P-38 Lightnings remain airworthy. These precious survivors appear at airshows, their twin Allison engines producing that distinctive sound that once struck fear into Japanese pilots. Watching a Lightning fly is like witnessing history come alive. The sleek silver fuselage catches the sun. The twin booms slice through the air with predatory grace. The aircraft moves like it's still hunting, still ready for combat, still carrying the spirits of the pilots who flew it into battle. Spectators who see the lightning fly often have the same reaction: stunned silence followed by thunderous applause. Even 80 years later, Kelly Johnson's design commands respect and admiration. The story of the P-38 Lightning is ultimately a story about belief in an idea everyone else dismissed, belief in mathematics over mockery, belief in innovation over tradition. One man, Kelly Johnson, looked at impossible specifications and saw opportunity instead of obstacles. His colleagues called it idiotic. Critics said it would never work. Conventional wisdom declared it aerodynamically absurd. But Johnson built it anyway, and his creation destroyed 5,000 Japanese aircraft, killed the architect of Pearl Harbor, and helped win the largest air war in human history. That idiotic idea became one of the most successful fighter aircraft ever built. It proved that sometimes the craziest concepts are actually genius waiting to be recognized. And it demonstrated that in war, in engineering, and in life, the difference between idiotic and brilliant often comes down to one thing: having the courage to try. The P-38 Lightning didn't just win battles. It didn't just destroy enemy aircraft. It changed what people thought was possible. It showed that unconventional thinking can solve unsolvable problems. It proved that one person's vision, backed by skill and determination, can alter the course of nations. Kelly Johnson's idiotic idea became America's fork-tailed devil, Japan's worst nightmare, and a symbol of American air power that still resonates today. 5,000 Japanese aircraft destroyed. Countless lives saved. One impossible mission accomplished. And it all started with an idea that everyone said would never fly. But it did fly. And when it flew, it changed everything. But there are stories within this story that deserve to be told. Stories of individual pilots whose lives intersected with the lightning in ways that reveal the human dimension behind those staggering statistics. Stories that show how a machine becomes more than metal and engineering, how it becomes hope, vengeance, survival, and redemption. Take Second Lieutenant Robert Petit, who on October 19, 1943, found himself in a situation that should have been his death sentence. Flying a photo reconnaissance mission over Rabaul, one of the most heavily defended Japanese bases in the Pacific, Petit's P-38 takes devastating hits from anti-aircraft fire. Shells tear through his right engine, which immediately catches fire. Flames stream back along the boom, melting aluminum, consuming fuel lines, threatening to engulf the entire aircraft. Standard procedure is to bail out immediately. But Petit is 50 miles from friendly territory, over water crawling with Japanese patrol boats. Bailing out means capture, torture, execution. He makes a different choice. He's going to fly this burning aircraft home or die trying. Petit shuts down the burning engine and feathers the propeller, but the fire won't stop. It's spreading, eating its way toward the central nacelle where he sits. The heat becomes unbearable. He can smell his own flight suit beginning to singe. The P-38 shudders and vibrates, damaged control surfaces fighting his every input. Flying on one engine, trailing smoke, losing altitude, Petit nurses the lightning toward Guadalcanal with a determination that borders on superhuman. Japanese fighters spot the crippled P-38 and move in for an easy kill. But Petit discovers something remarkable. Even on one engine, even damaged and burning, the lightning still has enough speed to stay ahead of the pursuing Zeros. He jinks and weaves, using every ounce of the P-38's remaining performance to stay alive. The chase lasts 20 agonizing minutes. 20 minutes of flying a burning aircraft while enemy fighters try to finish him off. 20 minutes that feel like 20 hours. Guadalcanal appears on the horizon. Petit is barely conscious now, overcome by smoke inhalation and heat. The fire has consumed most of the right boom. The aircraft is barely controllable. He lines up with the runway on what amounts to a controlled crash more than a landing. The P-38 hits hard, bounces, hits again and skids to a stop in a shower of sparks. Petit kicks open the canopy and literally falls out onto the runway as firefighters rush forward. The lightning continues burning, but Petit is alive. He survives because Kelly Johnson built redundancy into every aspect of the P-38's design. 2 engines. 2 booms. Separated systems. You can lose half the aircraft and still fly. This isn't theoretical. This is real, proven in combat by pilots like Petit who owe their lives to Johnson's genius. Then there's Major Thomas Lynch, whose story illustrates the Lightning's evolution from pure fighter to something far more versatile and lethal. By 1944, Lynch commands a squadron of P-38s in New Guinea, and he's developed tactics that turn the Lightning into a ship killer of terrifying effectiveness. Japanese convoys attempting to resupply isolated garrisons face a new nightmare. P-38s screaming in at wavetop altitude, 4.50 caliber machine guns and 120mm cannon concentrated on ship waterlines. Lynch perfects the technique. His pilots approach so low the Japanese ships can't depress their anti-aircraft guns enough to track them. At the last second, the P-38s pull up slightly and unleash concentrated fire directly at the waterline. The effect is catastrophic. Heavy bullets and cannon shells punch through thin ship hulls below the waterline, opening massive holes that flood engine rooms and cargo holds in seconds. On March 3, 1944, Lynch leads his squadron against a Japanese convoy off Wewak. 8 cargo ships, 4 destroyers, all desperately needed by Japanese forces starving for supplies and reinforcements. Lynch's P-38s hit the convoy like a hammer striking glass. They make repeated passes, each lightning-firing bursts that turn ship hulls into sieves. Japanese sailors abandon ship as vessels list and sink. Destroyers try to maneuver, their anti-aircraft guns blazing, but the lightning speed makes accurate shooting impossible. By the time Lynch's squadron breaks off the attack, 6 cargo ships are sinking or sunk, 2 destroyers are dead in the water and burning, and thousands of tons of supplies destined for Japanese troops are sliding beneath the waves. The P-38 has just demonstrated it can dominate not only air combat but naval warfare as well. Kelly Johnson's design proves so adaptable, so inherently sound, that it excels at missions never envisioned during its creation. But the Lightning story also includes moments of profound tragedy that remind us this is war, not adventure. Not every mission ends in triumph. Not every pilot comes home. Consider the fate of Lieutenant Colonel Charles McDonald, one of the Pacific's highest-scoring aces with 27 confirmed kills. McDonald is invincible in the air, a natural pilot with reflexes that border on precognition. He can see enemy aircraft before his wingmen spot them. He can predict their moves before they make them. Flying a P-38, McDonald is death incarnate. But on January 7, 1945, during a strafing run on a Japanese airfield in Luzon, McDonald's luck runs out. Ground fire catches his P-38 at low altitude. One engine explodes. The aircraft rolls inverted and plunges into the ground at 300 miles per hour. McDonald never has a chance to eject. He's killed instantly. 27 victories. Hundreds of combat hours. Irreplaceable experience and skill. Gone in 3 seconds. The lightning couldn't save him. No aircraft could have. War is random and merciless, killing the skilled and unskilled with equal indifference. Yet for every tragedy, there are stories of miraculous survival that seem to defy rational explanation. Flight Officer Harold Fisher's experience on April 29, 1945, falls into this category. Fisher is flying bomber escort over Okinawa when Japanese fighters attack his formation. In the swirling dogfight that follows, Fisher shoots down 2 enemy aircraft but takes hits himself. Cannon shells shred his left engine and tear through the cockpit, wounding him in the leg and shoulder. But that's not the worst of it. A 20mm round strikes directly between his legs, passing through the seat cushion and his parachute pack without detonating. Fisher feels the impact, certain he's been mortally wounded. He looks down expecting to see catastrophic injury. Instead, he finds a hole in his parachute pack and a dent in his seat. The shell was a dud. It didn't explode. Fisher is wounded but alive, and his P-38 is still flying despite massive damage. He makes it back to base flying on one engine with control surfaces hanging in tatters. When maintenance crews examine the aircraft, they count 73 separate holes from Japanese fire. 73 hits, and the lightning still brought him home. These individual stories accumulate into a larger truth about the P-38 Lightning. It wasn't just a machine, it was a partner, a protector, a lifeline for the men who flew it. Pilots developed almost superstitious affection for their assigned aircraft. They gave them names, painted nose art, talked to them like living things. This wasn't mere sentimentality. This was recognition that the Lightning kept faith with them. When everything went wrong, when combat damage should have been fatal, when fuel ran desperately low over endless ocean, the P-38 kept flying. It brought them home. That reliability created a bond between pilot and aircraft that went beyond professional respect into something approaching love. Veterans who flew the Lightning in combat universally describe it as the best aircraft they ever flew. Not because it was perfect, it wasn't, but because when their lives depended on it, the Lightning never let them down. The technical innovations embedded in the P-38's design influenced aviation development for decades after the war. Consider the tricycle landing gear, nose wheel instead of the traditional taildragger configuration. This seems like a minor detail, but it revolutionized aircraft operations. Tricycle gear provides better forward visibility during taxiing and landing. It eliminates ground loops that plague taildragger fighters. It allows higher speed takeoffs and landings. After the war, virtually every jet fighter adopted tricycle landing gear. Kelly Johnson pioneered this on the P-38, proving its advantages under the most demanding conditions imaginable. The counter-rotating propellers that eliminated torque effects became standard on twin-engine aircraft. The concentrated nose armament philosophy influenced jet fighter design worldwide. The emphasis on pilot visibility, with the P-38's greenhouse canopy providing excellent sightlines in all directions, set standards for fighter cockpit design. These weren't accidents. These were deliberate design choices made by an engineer who thought deeply about every aspect of aerial combat. The Lightning also played a crucial role in a mission that remains controversial to this day, the destruction of the Japanese submarine I-1 on January 29, 1943. American intelligence learns that I-1 is transporting critical documents and equipment to Japanese forces in New Guinea. P-38s are scrambled to locate and destroy the submarine before it can deliver its cargo. This represents a new type of mission, using fighters against submarines, something previously considered impossible. But the P-38's speed and firepower make it theoretically capable of attacking even armored submarines if caught on the surface. Lieutenant Joseph Miller spots I-1 running on the surface, recharging batteries. The submarine is huge, over 300 feet long, and its crew spots the approaching Lightning. They scramble to dive, but submarines are slow to submerge. Miller has perhaps 30 seconds before the sub disappears beneath the waves. He dives his P-38 almost vertically, building speed, then pulls up at the last instant and fires everything directly at the submarine's conning tower. Hundreds of rounds hammer the I-1's pressure hull. Miller can't sink it with machine gun fire alone, but he doesn't need to. The damage he inflicts prevents the submarine from diving. It wallows on the surface, taking on water through bullet holes, while Miller calls in B-17 bombers that finish the job. The I-1 sinks with all hands, its cargo lost. The P-38 has just demonstrated it can threaten even submarines. As 1945 progresses and victory becomes inevitable, P-38 pilots face a different kind of challenge. The Japanese Air Force is shattered, experienced pilots dead or grounded by fuel shortages. The enemy increasingly resorts to kamikaze tactics, suicide attacks where pilots deliberately crash explosive-laden aircraft into American ships. The P-38 becomes the first line of defense against these kamikaze raids. Combat air patrols of Lightning circle American naval task forces constantly, ready to intercept suicide planes before they reach the fleet. This is brutal, unglamorous work. The kamikaze pilots are often barely trained teenagers in obsolete aircraft, but their desperation makes them dangerous. P-38 pilots must shoot them down without mercy, knowing that every kamikaze that gets through means American sailors die. Lieutenant Philip Schlamberg intercepts a kamikaze formation on April 16, 1945, near Okinawa. 15 Japanese aircraft loaded with explosives, heading for the American invasion fleet. Schlamberg's flight of 4 P-38s engages them without hesitation. The Lightning's speed advantage is overwhelming. Schlamberg personally shoots down 4 kamikazes in less than 3 minutes. His wingmen destroy 6 more. The remaining Japanese aircraft break off, their mission failed. Below, American sailors who watch the dogfight cheer and wave at the Lightning pilots who just saved their lives. This is the P-38's final role in the Pacific War, guardian angel, protector, the shield that stands between American forces and Japanese desperation. When Japan finally surrenders in August 1945, P-38 pilots experience a strange mixture of emotions. Relief certainly. Joy that the killing has stopped. But also a kind of melancholy. The Lightning has defined their lives for years. It's been their workplace, their weapon, their salvation. Now suddenly it's over, and the aircraft that seemed so vital just days ago are being lined up for scrapping. Thousands of P-38s, too expensive to ship home, are bulldozed into pits and buried. Perfectly functional aircraft that cost thousands of dollars and countless hours to build are treated as disposable junk. Pilots watch with genuine sadness as Lightnings are destroyed en masse. These aren't just aircraft to them. These are the machines that kept them alive, that brought them through the worst war in human history. Watching them get bulldozed feels like watching friends die. Some pilots buy their own P-38s for a few $100s and fly them home as personal aircraft. Most can't afford even that. They say goodbye to their Lightnings and return to civilian life, carrying memories of aerial combat that will never entirely fade. The final word on the P-38 Lightning belongs to the enemy pilots who fought against it. Captured Japanese aviators, interviewed after the war, speak with respect bordering on fear about the fork-tailed devil. They describe it as the most formidable opponent they faced. Faster than the Zero. Better armed than anything in the Japanese inventory. Flown by pilots who grew increasingly skilled and aggressive as the war progressed. One captured Japanese ace, who survived over 200 combat missions, states flatly that he would rather face 4 American Corsairs than 2 P-38s. The lightning's speed meant it controlled every engagement. It could attack when it wanted and disengage when it wanted. Japanese pilots had no answer for this. They could only hope to survive when lightnings appeared. This testimony from the enemy provides the ultimate validation of Kelly Johnson's design. The aircraft worked exactly as intended. It dominated the skies. It destroyed the enemy. It brought pilots home. What more can be asked of a fighter? But perhaps the most extraordinary aspect of the P-38 Lightning story is how close it came to never existing at all. In 1937, after Kelly Johnson submitted his radical twin-boom design to the Army Air Corps, the proposal nearly died in committee. Military procurement boards are notoriously conservative institutions, and Johnson's design violated every conventional principle they trusted. The board members looked at sketches of the twin-boom configuration and saw a monstrosity. They saw complexity where they wanted simplicity. They saw risk where they demanded certainty. The vote to approve development funding came down to a single deciding ballot. One man, one vote, separated the P-38 Lightning from oblivion. If that vote had gone the other way, Kelly Johnson's design would have been filed away and forgotten. The Pacific War would have been fought with different aircraft, slower aircraft, less capable aircraft. American pilots would have faced Japanese Zeros without the Lightning's speed and firepower advantage. How many more would have died? How many battles would have been lost? How many months or years would the war have lasted? These questions have no answers, but they illuminate a profound truth. History balances on knife edges thinner than anyone realizes. The difference between triumph and disaster can be a single vote in an obscure procurement meeting. That near-death experience in 1937 wasn't the last time the Lightning program faced cancellation. In early 1942, after Pearl Harbor, some military planners argued for abandoning the P-38 entirely. It was expensive to build, complex to maintain, and required specialized training. Why not focus resources on simpler, cheaper fighters that could be produced in greater numbers? The debate raged through the winter of 1942 while American forces retreated across the Pacific. Then in March, P-38s scored their first significant victories against Japanese aircraft. The performance reports from combat pilots were enthusiastic, almost ecstatic. The Lightning could do things no other American fighter could do. The cancellation talk evaporated overnight. Sometimes a weapon system proves its worth not through statistics or testing, but through the unfiltered testimonies of warriors who staked their lives on its capabilities. The pilots loved the Lightning, and their love saved it from bureaucratic extinction. Kelly Johnson himself almost didn't survive to see his creation triumph. In 1943, Johnson travels to the Pacific Theater to observe P-38 operations firsthand and gather feedback for improvements. He flies as a passenger in a Lightning conducting a routine supply run to forward bases. Halfway to their destination, Japanese fighters appear without warning. The P-38 carrying Johnson engages in violent evasive maneuvers, diving and climbing and turning at the edge of its performance envelope. Johnson, strapped into the cramped radio compartment behind the pilot, experiences every gut-wrenching maneuver with nothing to do but hold on and pray. Tracers flash past the canopy. The sound of machine gun fire is terrifyingly close. The engagement lasts perhaps 3 minutes, an eternity for Johnson, who understands with absolute clarity that if his Lightning gets shot down, the entire future of aviation changes. He carries in his mind designs for aircraft that won't exist for another decade. The P-38 outmaneuvers the Japanese fighters and escapes. Johnson arrives at his destination white-faced and shaking but alive. He later admits it's the most terrifying experience of his life. Designing aircraft and flying in combat are two very different things. That brush with death gives Johnson a deeper appreciation for what he asks pilots to do. He returns to Lockheed with renewed determination to improve the Lightning based on combat feedback. Pilots report that the original cockpit heater is inadequate at high altitude. Johnson redesigns the heating system. They mention that the control wheel blocks visibility during certain maneuvers. Johnson modifies the cockpit layout. They request improved dive brakes because the Lightning's speed in a dive sometimes exceeds safe limits. Johnson develops new wing-mounted dive flaps. Every complaint, every suggestion, every piece of combat feedback receives serious attention. This iterative improvement process, this willingness to listen to the warriors who actually use the weapon, is a crucial part of the P-38's success. The Lightning that fights in 1945 is substantially different from the Lightning that entered service in 1941. More reliable, more capable, more refined. Kelly Johnson never stops improving his creation, never assumes the design is perfect, never stops learning from the men whose lives depend on his work. The human cost of developing and operating the P-38 extends beyond combat losses. Test pilots die proving the aircraft's capabilities. Factory workers die in industrial accidents during production. Ground crew members die servicing the aircraft under combat conditions. These deaths rarely make headlines or history books, but they're part of the Lightning's story. Consider the fate of test pilot Ralph Verdon, who on November 4, 1941, takes an early P-38 up to test new modifications at high altitude. At 30,000 feet, Verdon pushes the Lightning into a steep dive, building speed. At 20,000 feet, the aircraft begins to shake violently, a phenomenon called compressibility that occurs when airflow over the wings approaches the speed of sound. The controls lock up. Verdon cannot pull out of the dive. The P-38 continues accelerating downward, completely unresponsive to any control inputs. Verdon rides the Lightning down through 15,000 feet, 10,000, 5,000. He has time to bail out. The parachute on his back could save his life. But Verdon is a test pilot, and test pilots are a special breed. If he bails out, the data dies with him. If he stays with the aircraft, the wreckage might reveal what went wrong. Verdon stays with the Lightning all the way to impact. He dies instantly when the aircraft strikes the ground at over 500 miles per hour. But the wreckage provides crucial data about compressibility effects. Engineers study the twisted metal and develop dive flaps that prevent the problem. Hundreds of combat pilots never experience compressibility issues because Ralph Verdon chose to die gathering data instead of living by abandoning his aircraft. His name deserves to be remembered alongside the combat aces. As the war winds down in the summer of 1945, a strange phenomenon occurs among P-38 pilots. They begin to fear peace more than combat. This sounds absurd. Who fears the end of war? But it reflects a psychological reality. These men have spent years defining themselves as warriors. The Lightning is their identity. Combat is their purpose. What happens when the war ends? Who are they without the aircraft and the mission? Many pilots secretly hope for one more mission, one more engagement, one more chance to climb into the Lightning's cockpit and hunt the enemy. This isn't bloodlust. It's the recognition that something profound in their lives is ending, and they're not ready to let it go. Lieutenant James Watkins later describes the feeling in his memoirs: "We wanted the war to end. We wanted to go home. But we also wanted to stay forever, flying Lightnings over the Pacific, living that sharp, bright existence where everything mattered and nothing was certain." When the atomic bombs fall and Japan surrenders, many P-38 pilots experience genuine grief mixed with their relief. They're going home, yes. But they're also leaving behind the most intense period of their lives, and some part of them will forever remain in that cockpit, hunting through tropical skies, living on the edge between survival and death.